With a little bit of persuasive luck, I was able to fix this downstairs mini split unit. This morning, the unit was off and it was flashing code 31. And I did not know what that code meant because I didn't understand what it was. So I looked it up and it said it was the heat sensor, or the temperature sensor rather. I'll put this on turbo. I'll put all the modes together here. I always put it on turbo to start it off with, and then put it on the down vent so it's circulating a little bit better. Now this unit is working now. Actually, I prefer when that screen is off, and that's actually what woke me up, as the light button turns that off, so you don't have to see that. So this unit stopped working last night, and this is a problem with modern plastics. I was able to fix it, super easy fix, but just so that anyone else experiencing this problem understands how to fix it, and part of a problem that is broader with all modern electronics, which is this. The upstairs unit and the downstairs unit had the exact same cable chewed through by a mouse. And the mouse was able to climb onto the top of the unit, which is crazy that it parkoured its way up and up there. I have a little tiny mouse. I mean, it's maybe this big. It just got into the house maybe a few days ago, and it has been wreaking havoc. But it found this unit and chewed on this one exposed cable. And this is something that has been happening with modern electronics, especially in vehicles, in the last few years. I think it's been a little under a decade, but about a decade now, that the automotive industry and a lot of electrical wiring is now being coated in a new version of these plastics. Polyethylenes and polypropylenes previously were all subproducts of the manufacturing of gasoline or petroleum. And those long hydrocarbon chains were really good at making plastics. And so for decades and decades, the world had been using oil-based plastics, and oil is not a mouse's best friend, so they left them alone for the most part. However, in the last 10 years or so, I think it's a little bit less, a lot of manufacturers have been switching over to soybean-based hydrocarbons, as they are organic and reusable or renewable. And so in an effort to be greener, we're now going to create more green waste, because these are made from soybean oil, these casings, which makes them delicious for little mice who say, wait, that's a little rubberized piece of soybean, and they eat it. But needless to say, if you're seeing code 31 on your EG4 mini split, that is this little sensor, and I'll go upstairs and show you exactly where that is. So with the front flap folded up, that is a pretty hard clip pin surface, so you have to give it a good tug and make sure you walk the entire thing with prying it up. That little service panel I just removed here, it's just a regular Phillips, comes right out, and then it has teeth that hold it up in there. That gives you access to where this black cable, which is your thermostat or your temperature sensor, I guess, it reads, and you can see that has been chewed right off. And this wire sticks right out here. So normally that sticks out about an inch into this airspace. And there's a giant open grate right there. So the mouse was able to just wander along the top of this. And again, these are some parkour mice, because that is roughly 8 feet off of the floor. So that mouse somehow climbed up there and decided it wanted to be on top of that just to chew on this. And in the exact same evening, it chewed both of these sensors. So I think it doesn't like how cold it makes these. It's actually not a fan of the EG4s because it makes the house too cold. The mouse wanted it warm. It decided, hey, I could chew that sensor and solve my problem. So on the downstairs unit, it's not actually what happened, but maybe. So if you unhook this from this little clip area there, it gives you a little bit more slack, and you can see that this heat shrink sleeve is actually not shrunk onto it. It's just a sleeve on there. So if you undo this cable, now you have some slack, and you slide this sheathing back and expose those wires, you'll notice that one has a white line and the other does not. And that just tells you the polarity. So what I did is I cut this sleeve, since it's got a zip tie on it. I'll actually have to remove this zip tie because I don't think I have enough working room on this one for it. The other one had a little bit longer length. And then with those exposed, I'll do that real quick. I just slid that, and be delicate because these wires are 18 gauge, so they're very, very small, and it might be hard to see, but on one side of these wires, they are pre-indicated. There's the white dashed line there, and every inch or so, you'll see it again. And that is telling you that it is one side of this equation. Sorry for the dirty fingernails. I've been digging at this stuff all morning. And then I just snipped this with a little pair of scissors on my Leatherman, which if you don't have one of these Leatherman tools, I'll show you it. It is the handiest electrical working tool I have ever owned in my life. If I ever lost it, I would buy another one that same day. And then you pull back the sheathing on this, and you'll strip those wires just about in, I would say about 1/3 of an inch of exposed wiring, and then you'll break the two wires separate from each other. They're bonded together. So you'll cut down the center, and you'll put these really handy sleeve tools on it. And if you've never used these, I would recommend these 1,000 times over. They have them for all different gauge wiring. The ones that we're using is this white specific one here. And I should have showed you on the last one, but I'll do this one as a total project. This here, those little white rings, so the wire slides into it and then the other wire slides in. You kind of smush all the wires together in this center section. You then heat with a heat gun, and if you have a portable heat gun, it's even handier. I'll link all of these tools in the description because these, and including of these, because these I use constantly for electrical work and they are really nice. But the two wires slide in. You'll take caution to heat what would be the downhill side first. If it is not, if the wire's vertical, you would want to heat the bottom side first, and it will shrink this white gasket quicker around those wires to ensure that nothing is going to escape, and then kind of work your way up and then do the same on the other side. And then intensely heat the center section. And that is actually a ring of solder that is built into it. So as soon as this then seals this center cavity, that little piece of solder will then flow around all of the copper wires so that you can get a perfect bond. And I did this with the downstairs unit, used 2 of these, so one for each of the wires, and they're right next to each other. Normally you would want to offset or stagger those, but because of the length of the wire and they lacked of room to work with in here, we're just going to make it work, and that beats having to buy a new temperature sensor. So that worked this morning. Again, if you don't have the Leatherman Squirt ES4, this is just a little tiny Leatherman tool, but the cool part about this one is it's a wire stripper, and these are really sharp wire strippers. They really work exceptionally well, all the way up to 12 gauge wire. So you can actually do most household wire stripping. So like if you're doing your regular Romex in your house, you can use this for that. So for a regular tradesperson, this is extra small. So it has little scissors on there, a knife on there and everything, and I just keep it on a carabiner so I can clip it. But from a keep it in your pocket and you have wire strippers on you at all times size, this is the handiest tool I've ever purchased for electrical work. Definitely one of those. Love this DeWalt tool. This is the DCE 530, and this is, a lot of people make fun of the idea that it doesn't last a very long time, blah, 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 blah. Well, I have to turn the power off in this room in order to run that, or to take the power away from that. So now I don't have the ability to run a traditional heat gun in the space that I need to use this heat shrink stuff. So this is exactly what this is used for in these applications. I've also used this to heat pond liner to melt it back together again, but I digress. Needless to say, some simple tools, if you have them handy, you can solve this problem. But the root of this problem isn't just this wire. It is the type of material that it's coated in. So if you're experiencing that with outdoor equipment, again, my audience is probably a lot of farmers and DIYers. So if you're a farmer or you're about to put some solar on your roof, make sure you're using metal to guard that wire. Or if you know it's going to get clipped, or it does get clipped, have the right tools on hand to fix it yourself, because the cost of doing this yourself is fairly gratifying to solve the problem in the same day, but it's even better to have it solved and not be able to have to order a part or something like that. So I'll put those little sleeves on. I'll strip those wires. I can't do it because I'm always doing this one-handed. But I'll strip these wires. I'll part them. I'll strip them. And then I'll slide on those little sleeves. And I'll show you pre-heat gun what it looks like. And then post-heat gun what it looks like. Now with the wires stripped on both sides and parted, I'll be able to slide these little sleeves onto them. And I'll do one of them right now just so you can see what that looks like from a positioning standpoint. So you would want that sleeve to look just like that on one side, and I'll kind of one-handed do this here. I don't know if I'll be able to thread that well. Probably won't. It's the wrong side, but you get the idea. And this side, you have to make sure that the wire, the black part of the wire, passes through. And if I can do that one-handed, I'm sure most folks can do this with two hands. And you want to compress those in just like that. So what you'll see is the sleeve of the wire passes under this white ring, which clamps this heat shrink in place. Then those wires are all kind of frayed together. As this tubing shrinks, it pushes all the wires together, and then that solder flows in order to bond the two wires together electrically and physically through the metal. And I'll do the whole thing together, and then I'll re-slide this heat sleeve back over those, and it will look almost like nothing has ever changed. So I'll show you that in just a second. When you choose the right sleeve size, you'll notice that I'm not applying any pressure to that, and it's being able to hold it in place. But that's what it will look like, and then I will heat it up from here. I won't show that on video because it gets pretty loud, but it will just seal those together. And it isn't perfect, but you'll see, maybe it'll be a little bit easier if I zoom in, that solder has now flowed, and there's some tangling of the wires. It's not perfect, but as long as all of the wires have some contact within that tube to one another and the solder, you then have a completed circuit. And so again, that's all that was needed to fix these. I'll wrap that back up once this cools a little bit. I don't want to rip those apart because they're still really soft as you just heated them. I'll re-slide that upper sleeve back down onto this exposed area, and then I will use electrical tape to complete the job. And then I'll tuck that wire back in, put the service plate back on. I did take out the screens because I needed to clean those anyway. So it was good timing, but I will clean this up and then plug it back in, and it will be good to go. Let me know your thoughts if you've had to deal with rodents and eating those soybean-based wires. Links in the description for all of the tools.